Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 5 of a series of videos on financial mathematics. In case you've missed out on any of those videos, I'm going to link those videos in the description box below. Please go ahead and take a look at them. In this video, we're going to talk about how to use the amortization table to solve questions on loan. Let's start. The question for today is Jack receives a loan of $5,000 from a bank at an annual interest rate of 7.5% compounded monthly. Okay, so this is a good habit to just mark some of the key aspects of a question as you are reading along. It is to be repaid in monthly installments within a 5-year period. Determine the monthly installments in order to repay the loan on time. Okay, so we've got the loan, $5,000 from the bank. That's going to be the present value. The annual interest rate, that is per annum, right? Percent per annum, that's 7.5 compounded monthly. All right. And that's the, compounding period 12 times, right? It is to be repaid in monthly installments, payments per year. Okay. We got to pay back 12 times a year. And within a 5-year period, that means our number of payments is going to be 5 times 12. And we got to figure out the payment. That monthly installment is going to be that fixed amount, that constant amount that needs to be repaid back every month over that 5-year period. And so we need to find out what that monthly installment is going to be. So let's jump to our calculator and add a calculator page. We'll make our way to the finance solver. Here we go. N is the number of payments. So this is going to be 5 times a 12. Hit tab, not enter. Okay, hit tab to go to the next field. Because if you hit enter, it might give you an error message, okay? Interest is 7.5 and the present value is positive 5,000, okay? Because you are acquiring the loan, the money is coming into your hands. Payment is what we want to find out. That's going to be the monthly installments, the fixed amount that has to be repaid back every month. That's the idea of in the loans, right? When you have to repay back every month, that EMI as they call it, all right? Final value, FE is final value. The final value of the loan must be 0 after you paid back every installment over the 5 years. So that final value has to be 0. Payments per year is going to be 12 because that has to be paid every month. That's monthly installments. And compounding periods is also 12. That's being compounded monthly. And then, as we have seen in the earlier videos also, because it's a loan, normally the EMI has to be paid at the start of the month. And then we make our way to that payment field and there we hit enter. Okay, this is where you hit enter. Otherwise, you're just using tab or shift tab to maneuver across the different fields. You hit tab and you get the monthly installment. The monthly installment is indicated as negative because that's the money that's going out of your pocket. So I'm going to make a note of the monthly installments for Jack, which is going to be 99.57. I'm going to round it off to 2 decimal places. Okay, so that's going to be our monthly installments. Okay, part B. Look at part B of the question. It says Jack starts repaying the loan, the $5,000 loan, with monthly installments calculated in part A. So he starts paying back this amount, okay? Every month, that is, okay? Every month he's going to pay 99.57, almost $100 every month. Calculate the amount he still owes after the 10th installment. After the 10th installment. Now, for those of you who haven't seen part 4, where we discussed the idea of the amortization table, we went through details as to how to create the table and what each of those columns represent. And we want to find out how much amount he still owes after he's paid the 10th installment. So let's jump to the calculator. And this time what we're going to do is that we're going to create an amortization table, go to menu, finance, amortization and amortization table. And let's see whether we can recall the syntax. Okay, the first number that we're going to enter is going to be the number of entries, all right? Because we need, the question says that we want to find the amount at the end of, that he still owes after the 10th installment. Can you see that? Because we need the amount at the end of the 10th installment, the amount that he still owes the bank, we need at least 10 entries. So I mean, we need the 10th entry also. So when you put 10 onto that field, the first field, the table that's going to be generated is going to have from 0 to the 10th entry. That means each repayment, okay, the first repayment, the second repayment, the third repayment, all the way up till the 10th repayment. And at the end of the 10th repayment, the fourth column, the entry in the fourth column corresponding to the 10th repayment will be the amount that he still owes the bank. Okay, so I'm just going to enter 10. The next entry is going to be the total number of repayments. And that's going to be 5 times 12 because it's 5 years and 12 months. And so that's going to be 60. The next entry is going to be the interest, which is 7.5. Okay. And then the present value is the amount that the bank has loaned him, which is 5,000. Okay. And then is the payment. Okay. The payment is the monthly installments, which we calculated from the from part A. Now, there are two ways to do it. One is if you want to preserve accuracy, you can go to VARs and pull out that payment from here. Or you can just look at your answer and say, well, he had to repay 99.57. So you can enter 99.57. But because he's paying back to the bank and it's money that's going out of his pocket, make sure that you enter it with a negative sign. Okay, that's the money that leaves his pocket, right? So 99.57 with a negative sign. All right. The next entry is the future value, which has to be 0 because the loan has to be paid up in full. All right. In 5 years' time. Okay. Every month you're paying that fixed amount of 99.57 for those 16 monthly installments till it becomes 0. So that's why the future value is 0. Then comes the payments per year, which is going to be 12. And then comes the compounding period, which was compounded monthly, again 12. And then you can leave a blank for begin or end. Begin or end is actually indicating whether you're making that payment, that monthly payment at the start of the month or at the end of the month. You can just leave it as blank by, putting a comma there. And then you can indicate the degree of accuracy. 2 decimal places is good enough. Now, when you hit enter, you're going to get a table, as I said, from 0 to 10. And we needed only that 10 because we were interested in the amount of money that he owes at the end of the 10th installment. Each row corresponds to that installment. So 4 corresponds to the 4th installment. That means at the end of the 4th installment, he still owes $4,724.14. So at the end of the 10th installment, Jack owes, let me make a note of it. Jack owes, how much is that? $4,297.26. Okay, that is what you should write as the answer. Jack owes $4,297 at the end or after 10th installment. So this was a quick example to show you how you can answer questions like these, where you have to find out what is the amount that is owed after the end of a certain installment. In this case, it was the 10th installment. So we read that row corresponding to 10. Okay, that's the 10th installment. And that last column on your amortization table shows the balance. Okay, the balance that is still owed at the end of that particular installment. So when you go across the row corresponding to 2, that's the second installment, the amount that is still owed is 4862.93. And in the same way, if you're looking at the 8th installment, you look at that corresponding to the 8th installment, the amount at the end of the 8th installment, the amount that he still owes the bank is 4441.33. If you found this video useful, make sure that you hit the like button and subscribe to this channel. I'm going to see you all in the next video.